Good morning, my dear students. I am Dr. Evi Paramkusam, Professor in Department of ECE, Lendi Institute of Engineering and Technology. I have taught signals and systems, communication subjects for GATE students for last 10 years in various institutes like Vani Institute and GATE Forum Institute. In this lecture, I will explain about the operations on independent variable. The operations on independent variable. The operations on independent variable topic is very essential to solve some problems in GATE examinations. See here, suppose x of t is given. X of t is given. From this x of t, let us draw the x of t plus t naught. Simply x of t plus 2. Suppose x of t plus 2. Or x of t minus 2. Or x of 2t, or x of minus t, or simply x of 3t plus 2. So let us discuss about how do we obtain these signals from the x of t. See here, x of t plus 2 is nothing but right shifting. The x of t plus 2, sorry, it is not represents right shifting, left shifting. It represents left shifting. X of t plus 2 can be obtained by shifting the x of t to the left side by 2. Similarly, x of t minus 2 represents right shifting. The x of t minus 2 can be obtained by shifting the x of t to the right side by 2. Then x of 2t. X of 2t is nothing but it can be obtained by compressing the signal. X of t. By compressing the signal x of t. Compress x of t by 2. Suppose another signal is also there, x of t by 2. Then x of t by 2 represents expansion. Then you apply the expansion, that is expand the x of t by 2. You expand the x of t by 2. Then what is x of minus t? How do you get x of minus t? Time reversal. It represents time reversal. Then how do you obtain time reversal signal? Suppose x of t is there. You just fold the x of t signal about the y-axis. Whatever the values are there in the right side, that appear on the left side. Whatever the values on the left side, that values appear on the right side. Okay. So in this way, you can get x of minus t. Finally, x of 3t plus 2. In order to find x of 3t plus 2, see here, both the time scaling as well as time shifting. These operations are there. For example, suppose x of minus 3t plus 2 is there. In this case, time shifting, time scaling and time reversal operations. 3 operations are involved. Now the question is that which operation have to be performed first and which operation has to be performed in the second time and what operation has to be performed in the third time. Let us discuss the basic procedure to obtain x of at plus b. Then if you know the basic procedure to obtain x of at plus b, then all these signals can be obtained. For example, in this case, what is the a value? 1. What is the b value? 2. In this case, a is equal to 1, b is equal to minus 2. A is equal to 2, b is equal to 0. A is equal to 1 by 2, b is equal to 0. A is equal to minus 1, b is equal to 0. A is equal to 3 and b is equal to 2. If minus is there, a is equal to minus 3. Like that. Let us discuss the basic procedure to obtain x of at plus b. What is the basic procedure? Suppose y of t is equal to x of at plus b. X of at plus b. Here I will explain the two procedures to obtain x of at plus b from x of t. Y of t is equal to x of at plus b. So first you assume that an intermediate signal, that is g of t is equal to x of t plus b. Assume that g of t is equal to x of t plus b. Now you find g of at. Here the thing is that suppose if I give you f of x is equal to x square minus 3x plus 2. Then if I ask you to find f of 3, then how do you find? In place of x, 3 is there. So in the right side also, wherever x appears, in place of x you have to substitute 3, no? That this is equal to 3 square minus 3 into 3 plus 2. Similarly, g of t is equal to x of t plus b. In the left side g of t is there, in the right side x of t plus b is there. See here, in place of t, a t is there. So in the right side also, wherever t appears, in place of t, you just write a t. Then this is equal to t is there. You substitute with t, a t plus b. Okay, we got it. X of a t plus b by using only two steps. What is the first step? Shifting. Time shifting. What is the next step? G of a t. That is time scale. Time scale. Okay. So by using these two steps, we have got x of a t plus b. Let us discuss the second procedure to obtain x of a t plus b from x of t. First you apply the scaling. First you get an intermediate signal, that is g of t is equal to x of a t. X of a t. Okay. Next, let us find what is g of t plus b. G of t plus b. See here, in place of t, t plus b is there, no? In place of t, t plus b is there. So in the right side also, in place of t, you write t plus b. Then this is equal to x of a into t plus b. This is equal to x of at plus ab. At plus ab. So this is not equal to x of at plus b. This is not equal to x of at plus b. So this procedure is wrong. This procedure is wrong. Then how do you get x of at plus b? By first applying compression. In this case, we have applied shifting first step and compression as the second step. Then we get it. But in the second procedure, we have applied compression as the first step. Next step is time shifting. No, we did not get. Then what is the idea? To get the x of at plus b by applying compression as the first step. So instead of finding g of t plus b, let us find the g of t plus b by a. G of t plus b by a. Then this is equal to x of see, in place of t, t plus b by a is there. So wherever t is there, you substitute to t plus b by a in the right side also. X of a into t plus b by a. T plus b by a. This is equal to x of at plus b. At plus b. Okay, we get it. X of at plus b. So both the procedures are same. By applying the time shifting first step, time scaling second step, we get it. By applying time scaling as the first step, time shifting as the second step, we get it. But you just observe that. Time scaling, you apply the x of at. In time shifting, not simply t plus b, but t plus b by a. So that is the idea. Now we discuss we solve some problems by using the first procedure, because the first procedure it is as a simple procedure. Now we solve one problem. X of t is given. This is the signal x of t. Let us draw the x of 3t plus 2 and x of 4 minus t by applying the first procedure. What is the first procedure? Apply the time shifting as the first step. Next, time scaling as the next step. See, let us come to the first problem. Let us draw the x of 3t plus 2. That is, y of t is equal to x of 3t plus 2. Here a is equal to 3 and b is equal to 2. B is equal to 2. What is the intermediate signal? First we get, first step is the apply the time shifting. G of t is equal to x of t plus 2. X of t plus 2. X of t plus 2 is nothing but left shifting. The x of t plus 2 can be obtained by shifting the signal to the left side by 2. So now you shift this signal to the left side by 2 units. By 2 units. Okay. If you shift this signal to the 2 units, then this minus 2 becomes minus 4, this is minus 3, minus 2, minus 1 and 0. Okay. So this is g of t. This is g of t, that is equal to x of t plus 2. Okay, what is the next step? The next step is g of 2t. The next step is g of 2t. That g of, sorry, we have to get x of 3t, no? Then g of 3t. G of 3t. Then g of 3t is equal to, because g of t is equal to x of t plus 2. So you write in place of t, 3t here, 3t plus 2. Okay. So this is the problem that we have to draw the signal g of 3t. This is g of t, no? This is g of t. Apply the time scaling to the signal. Here, what is the value of a? A is greater than 1. So then compress the signal. Then compress the signal. How do you compress the signal? You just identify the some points. Identify the some points. Minus 4, minus 3, minus 2, minus 1, 0. Because at these points, the line expression will be changed. The line expression will be changed. So, see here, 3 is multiplied with t, no? So, at these points, you divided by 3. You divided by 3. Then the same points can be obtained at this value divided by 3. Minus 4 by 3. Minus 4 by 3, minus 3 by 3, that is equal to minus 1, minus 2 by 3, minus 2 by 3, and minus 1 by 3, and 0 by 3, 0. See, between minus 4 and minus 3, this shape is there. This shape is there. So, between minus 4 by 3 and minus 1, then we have to draw the same shape. Shape. Okay. The amplitude does not change. The amplitude does not change. The amplitude does not change. Okay. Next, minus 3 to minus 2. A straight line is there, constant. See here, minus 1 to minus 2 by 3, constant. So you continue it. Okay. This is x of 3t plus 2. Okay. Now we solve the second problem. Now we solve the b bit. Obtain x of 4 minus t from this signal. So first you get the g of t. Here what is the value of a? A is equal to minus 1 and b is equal to 4. G of t is equal to x of t plus 4. Because b is equal to 4. So for the first step is time shifting. Next, you apply the scale. What is g of minus t? G of minus t. If g of t is equal to x of t plus 4, what is g of minus t? In place of t, minus t is there. Wherever t is there, you apply the minus t. Then this is equal to x of minus t plus 4. X of t minus t plus 1, that is x of 4 minus t. So this signal is obtained by applying the time shifting as well as time reversal. Only two steps. X of t plus 4. How do you get x of t plus 4? X of t plus 4 is a signal that can be obtained by shifting the x of t to the left side by 4. Then x of t plus 4 can be obtained. Minus 2 will be coming to the minus 4, minus 6, minus 5, minus 4, minus 3, minus 2. Okay. So this is the signal. This is the value 2, minus 2. This value is equal to minus 1. Okay. This is x of t plus 4. This is g of t, that is equal to x of t plus 4. Now we have to get the g of minus t. G of minus t. So g of minus t, how do you get g of minus t? By simply fold the signal about the y-axis. Then whatever the signal values are there in the right side, that appear on the left side. The values in the left side appear on the right side. Now you fold this signal about the y-axis. Then this is -1, 0. Now you fold the signal about the y-axis. Then this is g of minus t. Then this is g of minus t. Minus t. 0, 1, 2, 3, 4, 5, 6. Okay. This line is from -2 to -3 now. Then you will get 2 to 3 and 3 to 4, 4 to 5, 6. This value is equal to 1, 2, and this value is equal to -1. This is x of 4 minus t. So in this way you can get any signal from x of t by using the first procedure. Okay. Now I will explain a shortcut method to obtain these signals without applying this procedure. Now I will explain how we get x of 3t plus 2 with shortcut method. With simple steps, let us discuss how we get x of 3t plus 2. See, this is the signal x of t now. First you identify the some points such that suppose this is A, B, C, D, E. Why we identify these as the important points? Because between any two successive points, the expression for x of t can be expressed by single expression. Suppose between -2 and -1, the x of t can be expressed by single line expression. Single line expression. Between B and C, it is expressed by single line expression. Of course, that single line is a constant. Between C and D, single line expression. Between D and E, single line expression. First, you identify that points. Assume that is S. S is equal to A, B, C, D, and E. Now you write these values: -2, -1, 0, 1, and 2. Okay. Now we have to get the x of 3t plus 2. Now, what is the argument here? 3t plus 2. You write that argument 3t plus 2. You make it equal to 3t plus 2 is equal to s. 3t plus 2 is equal to s. Then what is the value of t? T is equal to s minus 2 by 3. S minus 2 by 3. Now you find the points for t. Now you find the points for t by assuming that these are the points for s. Let that are A, B, C, D, E. A, B, C, D, E. If s is equal to -2, what is the value of t here? You substitute this -2 here. Here. -2 minus 2, -4 by 2. -4 by 3. And b is equal to -1. You substitute -1 here. -1 -3 by 3. That is equal to -1. And 0 minus 2 by 3. -2 by 3. And 1 minus 2, -1 by 3. 2 minus 2, 0. Now, these are the new points. These are the new points for x of 3t plus 2. These are the new points for x of 3t plus 2. Now, I draw the x of 3t plus 2 like this. X of 3t plus 2. First, you locate these new points. -4 by 3. Suppose this is -4 by 3. -1. -2 by 3. -2 by 3. And this is -1 by 3. -1 by 3. This is 0. -4 by 3. This is -4 by 3. Okay. These are the points A, B, C, D, E. Now the final answer is very simple. You just identify the line segments between any two successive points. Now you draw that line segments between the same points. Between A and B, this portion is there. Between A and B, this portion is there. So here also between A and B, you draw the same line. Okay. The amplitude does not change, -1. Similarly, between B and C, a constant line is there. Constant line is there. Between B and C, you draw that constant line. The value is 1. Between C and D, a constant line is there with value 2. Between D and E, a straight line is there with some slope, with a negative slope, of course. Yeah, this is x of 3t plus 2. This is x of 3t plus 2. Let us solve the x of 4 minus t, that is given in the second problem, B bit. Now I will explain how we get x of 4 minus t by using this shortcut method. See here, what is the argument here? 4 minus t. You write 4 minus t. Already we have obtained points for S, A, B, C, D, E. That values are -2, -1, 0, 1, 2. Okay. Now 4 minus 2 is equal to S. Then t is equal to 4 minus S. 4 minus S. Okay. Then you get the points for t. By substituting the values from this set. You substitute s is equal to -2. 4 minus of -2. That is 4 plus 2, 6. 4 minus of -1, 5. 4, 3, 2. These are the points A, B, C, D, E. A, B, C, D, E. Here I draw the x of 4 minus t. X of 4 minus t. First you locate these points 6, 5, 4, 3, 2, 0, 1, 2, 3, 4, 5, 6. See here, the point you also locate A, B, C, D. A, B, C, D. This is A, B, C, D, E. Okay, now you draw these line segments between these points. Here also, between A and B, this line is there. Between A and B, this line is there. So you draw the line like this. Of course, this value is equal to does not change. That is equal to -1. Between B and C, a constant is there of value 1. Between C and D, a constant is there with value 2. Between D and E, a line is there with a negative slope. Okay, this is x of 4 minus t. So in this way, you can draw any signal by using this simple procedure. Okay. After this, I will explain some problems which are given in the GATE examinations. To solve that problems, the knowledge on this topic is very essential. Here in GATE 2004, the problem is given, that is, let x of t and y of t with Fourier transforms x of f and y of f respectively be related as shown in figure 1 and 2. This is figure 2. This is figure 2. This is x of t. This is x of t and this is y of t. Okay. Then the question is that find the y of f. Find y of f. The options are given by A, B, C, D. Let us solve this one. Just now we have discussed if x of t is given, how do you draw the x of at plus b by using the shortcut method. But in this problem, x of t is given, y of t is given. We don't know what is the relationship between x of t and y of t. If you know the relationship between x of t and y of t, then you apply the Fourier transform on both sides, then you will get expression for y of f in terms of x of f. That's okay. But here the figures are given. Our job is to find the relationship between x of t and y of t. So let us apply the what are the shortcut method we have discussed to obtain the relationship between these two. Here x of t is given. Assume that this is a and this is b and this is c. Then the points S is equal to a, b, c. A, B, C minus 2, 0 and 2. Next, y of t is given. Suppose y of t is equal to x of a t plus b. X of a t plus b. Let us find the value of a and b. Okay. What is the argument here? A t plus b. Assume that a t plus b is equal to s. Then t is equal to s minus b by a. S minus b by a. Let us find the points for t. You write a, b, c. How do you get the points for a, b, c in the t? You have to apply these values in place of s. If you substitute minus 2 in place of s, then you will get value of t for the corresponding a. If you substitute minus 2, then minus 2 minus b by a is equal to a point. What is the a point here? Minus 2. This is a, this is b, this is c. So this is equal to minus 2, minus 1 and 0. Okay. So this is equal to minus 2. So minus 2 minus b is equal to minus 2a. So this is one expression. Let us substitute b is equal to 0 here. Then 0 minus b by a is equal to minus 1. If you substitute b value here, you will get the corresponding value to the b, that is equal to minus 1. That is equal to minus b is equal to minus a. That is nothing but b is equal to a. Okay, this is the second equation. The third equation is that you substitute 2 in place of s. Then 2 minus b by a is equal to 0. Then 2 minus b is equal to 0 and b is equal to 2. Okay, we get it. B is equal to 2. B is equal to 2. When b is equal to 2, you just observe this one. B is equal to a. So a is also equal to 2. A is also equal to 2. So a is equal to 2, b is equal to 2. So actually this is x of 2t plus 2. X of 2t plus 2. But you observe one thing is that the value of x of t here positive. But here the value of y of t is negative of this signal. So actually this is minus x of 2t plus 2. So y of t is equal to minus of x of 2t plus 2. See how that shortcut method can be applied very easily to obtain the relationship between these two. Of course, any student can also get a relationship between these two signals by simply intelligently thinking. Suppose the signal is shifted to the left side and after that compression, then by applying this procedure, this signal is obtained from this one, then he can intelligently find out. But by using this procedure without any hard work, you can get the relationship between these two signals by using this procedure. See, after getting this one, the expression for y of f simply obtained by applying the Fourier transform on both sides. See here, y of t is equal to minus of x of 2t plus 2. So how do you get x of a t plus b from x of t? The simple procedure. First you get g of t, that is equal to g of t is equal to x of t plus 2. Here both the procedures, the shortcut method is useful, and here also the method that we have discussed. In order to obtain x of a t plus b, first you apply the time shifting, next time scaling. That procedure also useful in order to get the Fourier transform. then g of t is equal to x of t plus 2. No? So this is the first step. The next step is that what is g of 2t? So you minus sign is there, you write minus sign here. What is g of 2t? This is equal to minus of, in place of t, 2t is there. In the right side also, wherever t is there, you substitute 2t, minus x of 2t plus 2. Okay. So in order to get minus x of 2t plus 2, first you get g of t, that is minus of x of t plus 2. So first you apply the Fourier transform on both sides of this equation. Then g of f is equal to minus what is the time shifting property? The Fourier transform of x of t plus 2 is equal to x of f into e to the power of minus j plus j 2 pi f into 2 because time shifted by amount 2 e to the power of j 2 pi f into 2. Okay. Now you apply the Fourier transform on both sides for this equation. Apply the Fourier transform on both sides. Then if you apply the Fourier transform on both sides, then what is the Fourier transform of g of 2t? This is equal to y of t, no? This is equal to y of t. So y of f is equal to the Fourier transform of g of 2t. According to time scaling property, the Fourier transform of x of at is equal to 1 by mod a into x of f by a. So then y of f is equal to the Fourier transform of g of 2t. The Fourier transform of g of 2t is equal to 1 by 2 g of f by 2. This is equal to 1 by 2. We know the g of f. Can you write g of f by 2? Very simple. In place of f by 2 is there. Then in the right side also, wherever f is there, you substitute f with f by 2. So minus x of f is there. In place of f, you write f by 2. E power j 2 pi f by 2 to get cancelled. F by 2 into 2 to get cancelled. So this is the answer. So out of these 4 options, B is the correct option. Now we will discuss another problem which is given in the GATE. In GATE 2006, one problem is given. The statement of that problem is that let x of t and x of j omega be the Fourier transform pair. That is, the Fourier transform of x of t is equal to x of j omega. That is, x of t and x of j omega be the Fourier transform pair. The Fourier transform of this signal x of phi t plus 3 in terms of x of j omega is given by. 4 options are given. Let us solve the problem. That is the Fourier transform of x of phi t plus 3. In order to find the Fourier transform of this one, we need to apply the properties of the Fourier transforms. The two properties are time shifting property and time scaling property. Just now we have discussed that suppose y of t is equal to x of phi t plus 3. First we have to write g of t is equal to x of t plus 3. Then the x of phi t plus 3 can be obtained by simply applying scaling, that is g of phi t. If g of t is equal to x of t plus 3, then g of phi t, in place of t, phi t is there. So in the right side also, in place of t, you substitute phi t. Then this is equal to x of phi t plus 3. Okay. So first you get the time shifting, then apply the time scaling to get the x of phi t plus 3. Now we need to find the expression for the Fourier transform of x of phi t plus 3. So first you apply the Fourier transform on both sides of this equation. Then the Fourier transform of g of t is given by g of j omega. Is equal to, what is the Fourier transform of x of t plus 3? According to time shifting property, if the Fourier transform of x of t is given by x of j omega, then the Fourier transform of x of t plus or minus t naught is given by x of j omega into e power j omega t naught plus or minus. If plus is there, then x of omega will be multiplied with e power j omega t naught. If minus is there, then x of j omega will be multiplied with e power minus j omega t naught. Here we need to find the Fourier transform of x of t plus 3. X of t plus 3. Then the Fourier transform of x of t plus 3 is given by x of j omega into e power j. In place of omega you can write 2 pi f. 2 pi f into 3. 2 pi f into 3. Okay. Next. Now you apply the Fourier transform on both sides of this equation. Fourier transform on both sides of this equation. So for this we need a time scaling property. What is the time scaling property? If the Fourier transform of x of t is given by x of j omega, then the Fourier transform of x of at is given by the Fourier transform of x of t is given by 1 by mod a x of j omega by a. X of j omega by a. So according to that expression, the Fourier transform of g of phi t is given by the Fourier transform of g of phi t. What is g of phi t? Actually this is y of t. This is y of t. That is equal to y of t is equal to x of t plus x of phi t plus 3. Suppose. Then the Fourier transform of g of phi t is equal to y of j omega is equal to 1 by mod phi g of j omega by phi. See here, g of j omega is given by this expression. G of j omega is given by this expression. Now you get the g of j omega by phi. This is equal to 1 by phi, mod phi is equal to phi. G of j omega is equal to x of j omega to e power j 2 pi f 3, no? So this is equal to x of j omega into e power j omega by phi. So this is g of j omega. We need g of j omega by phi. Wherever j omega is there, you just substitute by j omega by phi. E power j 2 pi f 3 by 5. Okay, here omega is there, j omega is there. In place of j omega, you have to substitute j omega by 5. J omega by 5. So this is the answer. This is the answer. So out of these 1 by 5 e power j omega 3 by 5, that is this is j omega and x of j omega by 5. So this is the correct option. And of course, I will explain you the direct expression for Fourier transform of x of at plus b. X of at plus b. See, so you can directly apply that formula. Suppose y of t is equal to x of at plus b. X of at plus b. Suppose in order to find this x of at plus b, first we have to find g of t is equal to x of t plus b. No? Then y of t is equal to g of at. G of at. First you apply the Fourier transform on this expression. Then you will get g of omega is equal to you can write g of omega, g of j omega. That doesn't matter. X of omega into e power j omega into b. Then apply the Fourier transform on this expression. Then y of omega is equal to g 1 by mod a g of omega by a. So now g of omega is equal to this. Now you get g of omega by 5, that is 1 by mod a x of omega by a g power j omega b by a. So in this way you can find the Fourier transform of any type of signal. Suppose if you are asked to find what is the Fourier transform of x of minus t plus 4 or x of minus t minus 1. or x of t minus or minus 2t plus 3. Suppose any type of signal. See here, what is the value of A? A is equal to minus 1, B is equal to 4. Here A is equal to minus 1, B is equal to minus 1. Here A is equal to minus 2, B is equal to 3. For example, I will find the Fourier transform for this signal. X of minus t plus 4. What is the value of A? A is equal to minus 1 now. So what is the expression? If you remember this expression, then you can write directly. 1 by mod A. A is equal to 1. So 1 by mod minus 1 into x of omega by A. Omega by A means A is equal to minus 1 e power j omega b by A. B is equal to 4, A is equal to minus 1. So this is equal to x of minus omega into e power minus j 4 omega. Simple. If you remember this expression includes both the time shifting as well as time scaling. Okay, you can write directly the Fourier transform for that signal. So this is the explanation, and now I explain. I will solve another problem which is given in the GATE 2005. This is the problem which is given in GATE 2005. The statement of the problem is that for a signal x of t, the Fourier transform is x of f. Then the inverse Fourier transform of x of 3f plus 2. The inverse Fourier transform of x of 3f plus 2 is given by 4 options are given. We need to find the inverse Fourier transform of x of 3f plus 2. So till now we have solved x of at plus b, the Fourier transform of x of at plus b. Now we try to solve inverse Fourier transform of a signal which is in the form of x of at plus b. See here, suppose y of f is equal to x of 3f plus 2. X of 3f plus 2. So how do you get x of 3f plus 2 from x of f? By using two steps. First step is a time shifting step, and second step is time scaling step. Of course, you don't say time here, frequency. First step is frequency shifting, and the second step is frequency scaling, because the scale is independent variable is f. Okay. First you get the intermediate signal g of f is equal to x of f plus 2. X of f plus 2. Next, the y of f can be obtained simply g of 3f. G of 3f. You see, g of f is equal to x of f plus 2. Now, what is g of 3f? G of f is equal to this. G of 3f is equal to, in place of f, 3f is there. So, in place of f, you substitute 3f. Then this is equal to x of 3f plus 2. Okay. Now, in order to find the inverse Fourier transform of x of 3f plus 2, we need to find the inverse Fourier transform of g of f. Then, find the inverse Fourier transform of g of 3f. So, first you apply the inverse Fourier transform on both sides of this equation. So, if you apply the inverse Fourier transform on both sides of this equation, then the inverse Fourier transform of g of f is equal to g of t. The inverse Fourier transform of x of f plus 2. In order to get the answer for this inverse Fourier transform of x of f plus 2, you need to apply the frequency shifting property. What is frequency shifting property? If the Fourier transform of x of t is equal to x of f, then the Fourier transform of x of t into e power j 2 pi f naught into t is given by x of f minus f naught. X of f minus f naught. See here, if it is plus, then you will get minus. So you write plus or minus, minus or plus, like this. Okay. See here, the inverse Fourier transform of x of f plus 2 from that expression can be obtained very simply. So that is x of t into e power j 2 pi f naught. What is f naught here? 2. F naught is equal to 2. 2 pi into 2 into t. So this is equal to x of t into e power j 4 pi t, e power j 4 pi t. So here plus sign is there, so we need to put minus sign here. We need to put minus sign here. E power minus j 4 pi t. Okay. So g of t is obtained. G of t is obtained. The next step is apply the inverse Fourier transform on both sides of this equation. What is the inverse Fourier transform of g of 3f? Inverse Fourier transform of g of 3f. In order to find the inverse Fourier transform for this one, first you write time scaling property. If the Fourier transform of g of t is given by g of f, then what is the Fourier transform of g of at? That is 1 by mod a g of f by a. G of f by a. Here I have g of 3f. G of 3f. So assume that a is equal to 1 by 3. Assume that a is equal to 1 by 3. Then what is the Fourier transform of g of t by 3? Is equal to 1 by mod a. That is equal to 3. 3 into g of 3f. G of 3f. Then inverse Fourier transform of 3 into g of 3f is equal to, the Fourier transform of this is equal to this one. The inverse Fourier transform of this is equal to g of t by 3. G of t by 3. Okay. Then the inverse Fourier transform of only g of 3f is equal to, that 3 goes right side. Then it is equal to 1 by 3 g of t by 3. Okay. What is g of 3f? G of 3f is nothing but x of 3f plus 2. So the inverse Fourier transform of x of 3f plus 2 is equal to 1 by 3 g of t by 3. But what is g of t? G of t is equal to x of t to e power minus j 4 pi t, no? So, what is g of t by 3? G of t by 3 is equal to x of t by 3 e to the power of minus j 4 pi t by 3. So, this is the answer. This is the answer. So, 1 by 3 x of t by 3 e to the power minus j 4 pi t by 3. So, the option B is correct. So, the option B is correct. Thank you very much.